channel, and we're continuing on in Chapter 4, learning about forces and simple machines. This is a little bit different lesson, as normally I just give a lecture and explain the different concepts. But in this case, I'm going to give a demonstration to help you understand more about first-class levers. So this is lesson 58, and we're going to be studying pages 82 and 83 in your student book, and activity manual pages 65 and 66. We're going to start in our student book first, and then we'll go to our activity manual. So let's go right there. It says, have you ever watched two people try to balance on a seesaw? A seesaw is a kind of lever. You know what kind of lever? First-class lever. What happens when one person is heavier or has more mass than the other? To balance the seesaw, the people must move to different positions. In this activity, you will find out how the distance between the effort and the fulcrum affects the effort needed to balance a lever. All right, so wherever the fulcrum is, it's going to change how much effort you need to balance it. Okay, so we're going to set the student book aside for just a moment. And I have everything pretty much set up, but we'll go over these different things so you know what to get if you want to try this at home. All right, so whenever we do a science experiment, we always start with a problem. And that problem is usually in the form of a question. So looking on page 65 in your activity manual, there's a problem at the top of the activity, and we need to try to answer that. Okay, so it says, how does the position or where the fulcrum is affect or change the amount of effort needed to balance the load? So wherever the fulcrum is, how does that change the effort? And what were we trying to do? We're trying to keep it balanced. Okay, the next part of our experiment, and this is what we call the scientific method, is we need to list the materials. What are you using in your activity? All right, well, there's a list for you already. You don't have to write this down. First thing we need is clay. This is Play-Doh. And if you're here in Korea like I am, you can go to this awesome store and get a lot of these materials from a place called Daiso. Or if you're in America, you can probably find all of this at a dollar store. You need an empty spool of thread. And if it's not empty, I think it still will work. Okay. Then you need what is called, it mentions a Chanel wire. Now, the Chanel wire is just another fancy word for pipe cleaner. Okay. And then you need a centimeter ruler, and yes, it does need to be centimeters because this is what we use in the scientific world. We use millimeters, meters, centimeters, and kilograms, grams, milliliters, liters. That's what we use for measuring in science. So it has to be a centimeter ruler. Then we need also 2 little cups, all right? And to help you understand, to help you see it a little better, I did mark it effort and load. Okay. And then I have my trusty little dog to give me the tape I need, but you'll need some tape. And then, of course, and I brought these back from America, this is about 100 pennies. You only need about 50 in this activity, unless you want to play with more positions on the centimeter. Okay? All right. So these are all of our materials that we need. And then the next part in our scientific method, this is what we call the hypothesis. Let's say that, hypothesis. Now that's a really big word. But the hypothesis, this is really important. What that does is what we're doing in here is we're guessing basically what will happen in the experiment. Okay? It's a guess or what we think might happen. So let's look. Most of the hypothesis is written for you, but you need to fill in a missing word. So let's read it together. It says, the closer the fulcrum is to the load, does it need lesser or greater the amount of force to balance the load? Okay, I'll say it again. The closer the fulcrum is to the load, the lesser or greater the amount of effort is needed to balance the load. Okay, so you choose. You think about what we learned the last lesson about levers. how do we going to balance this? Do we need more force or less force if the fulcrum is closer to the load? Okay? All right, think about that. So choose a word. All right, so let's go ahead and put this together. Now, I'm going to set this aside for just a moment, and we'll come back to it so we can assemble our first class lever. All right, so we take our ruler and our spool, and we place it. I'm going to put the numbers facing you, all right? And we're going to run the pipe cleaner right through the middle of the spool. And we're going to bring it up to the top, kind of even. And we're going to twist it as close as we can to the ruler. I'm going to twist it, and we're going to keep twisting it. We want to try to make that as tight as possible. Okay, that will really help. And we can just kind of let them hang off on the edge. Okay, and it won't bother anything. All right, so we got the makings of our first class lever. All right, now we're going to take the effort, and this tape takes about 2 pieces. That way it's secure, and we're going to put it near the 0. Okay, and you want to line up the edge of the cup with the edge of the ruler. Okay. And it's very important that you try to line up both sides with the edge of the ruler. Okay, and then you're going to do the same thing with the load. 2 pieces of tape is more than sufficient. We're going to set our tape aside. And then go ahead and tape the load. Sometimes it's not cooperative. Try to make sure that it's on the edge. All right, I want to tape the other side. And then this is where this clay comes in. We're going to just use this to kind of secure. You don't need a big piece, just a small ball of clay like that. All right. And you can set the rest to the side and play with it later. Okay. Roll it into a ball. And what we're going to do is we're going to set it right in the middle. Make sure that you can see. All right. And we're going to place that spool right in our clay. And that'll help it to stay secure. Keep it from moving anywhere. All right. And then what we're going to do is we're going to put it approximately at 15. You want to try to balance it as much as possible at 15. All right, so we got our first class lever. All right. So right now it's balanced, and what we're going to do now, we have our pennies. And we're going to put 10 pennies in each. All right, so 1, 2, 3, 4, 5. Effort. 6, 7, 8, 10. And then we're going to put 10 in our 3, 6, 7, 8, 9, 10. And put it in the load, all right? And it might have shifted a little bit, so you want to kind of wiggle it a little, make sure it's even. And it's really important that it's even. Okay. Now, that is in the middle. Let's try to turn it around, make it even with my camera. Okay, and my effort shifted just a little bit, so we got to make sure that it's right in the center. All right, that's pretty good. All right, so it's balanced. Let's set this aside so you can see this clearly. And now we're going to come back to our activity manual. All right. So we already did our hypothesis. Let's see what's going to happen in our procedure. So we're going to put the fulcrum at different positions on our ruler. And so it says 13, 18, and 10 centimeters. So each one we're going to move. Now I'm going to try to hold it where it's you can't see what's going to happen. And you need to tell me what you think will happen. Okay? So right now it's balanced. Now I'm going to move the effort. Okay? I'm going to move the position of the fulcrum, and I'm going to move it to number 13. Now, what do you think will happen in this case now? Before it was equal, and now I move the position. Okay, what do you think is going to happen? Okay, so 1. Okay, and before I let go, do I need fewer or do I need more pennies to balance the load? Okay, so write that word, fewer or more. Fewer or more. I'll give you a second. All right, 1, 2, 3, and we'll let it go. Uh-oh. Let's see here. What did we say before in our last lesson? The greater the distance, the less effort. Well, here it's not a great distance anymore. Okay, the distance got shorter. So what do we need to do now? We need to add more effort. So shorter the distance, more effort we need. Okay, so we need to pull our pennies back. All right, let's grab a few pennies and we can count all together. All right, so was your prediction right? Do you need more or do you need fewer? Well, so in the next section, the next column, we need to write more. I don't know what your prediction was, but now the result, what we actually did, we need more. So write the word more in that line where it says 13 centimeters. So let's count how many pennies we need to balance this. 1, 2, 3, 4, 5, 6, 7, almost, maybe one more, 8, a little, yeah, just about right. Maybe between 7 and 8 pennies that we needed. Okay, so you can write that number. We'll say 8. That's approximately, because it shifts a little bit when we try to balance it. Okay, so it shifts a little bit. So it needs about 8 pennies, 8 more pennies, meaning we need more effort to balance this. Why? The fulcrum is closer to the effort. So right, let's try this again. Let's take those pennies out as carefully as possible. 1, 2, 3, 4, 5, 6, 7, 8. All right. Now let's go ahead and put it back at the 15. Should be balanced. All right, here we go. Now it's balanced again. Okay. Now we're gonna move the position to 18. That means it's gonna go this direction. Okay. All right. So we're gonna move to 18, and before I let it go, what's the prediction? Do I need fewer, less, or do I need more? What do you think? I'll let you write that down in the prediction. Okay, I'm going to let it go in 5, 4, 3, 2, 1. Uh-oh. What do we need to do to balance this? That's right, we need to take away pennies. So let's go ahead and take some of these away. How many less do we need? So there was 10 in here. Let's start with 3 in here. Okay, let's start with 3. So I took away 7. Whoa! That's pretty good. So I need less, well, maybe 1 more penny. It's not quite balanced. All right. That's pretty good. And it shifts a little bit because it's not exactly tight. There we go. I took away 1, 2, 3, 4, 5, 6 pennies. So what was our result? Fewer pennies. And you can write that down. 6 fewer pennies. All right, fewer pennies. All right, we got 1 more. We can put it back to 15. We can put these pennies back in here, kind of shake it up a little bit and try to balance it. You can do this at home very easily by, there we go. You can do this at home. All right, so now we're going to move it to 10. Okay, so in this case, it's going to go this way. So the fulcrum's going to move closer to the effort. All right, what do you think is going to happen? All right, so the fulcrum, move closer to the effort. All right, what do you think is going to happen? All right, put your prediction down. Do you need fewer pennies in the effort or more pennies in the effort? Why? Because the fulcrum is closer to the effort. Okay, ready? 1, 2, 3. Oh no, what do we need to do? We need to add more. So our result is more pennies. Let's count how many more pennies we need. All right? We might need quite a bit, so I'll get a handful. All right, count with me. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, oh my goodness, 14, 15, 16, 17, 8, oh, starting to move, 18, 19, almost there, 20 to balance it. And it shifted just a little bit, so I'm just going to move it just slightly. Whoa, 20 more pennies. That was so much more effort. You see how making the fulcrum closer to the effort makes so much more effort required to balance this. So, what do we need in a first-class lever to make work easier? And that's the idea of a machine. What do we need to do? We need to move the fulcrum closer to the load, like our picture in our lesson the other day, or the previous lesson. Okay, so now what you need to do, there's one more step when we do an activity like this, and this is called the conclusion. So if you look on page 66, there are 4 or 5 questions here that helps you to understand what you did in your procedure, and it gives your thoughts on what happened. So your homework for this would be to finish page 66 in your activity manual, and maybe you can discuss with your parents what you learned today about a first-class lever. I hope you enjoyed this, and I'll see you next time.